Hello and welcome everyone to another Austin Python Meetup. Thank you for joining us this October. We're here with Cameron James, who's going to be showing us her project, MoviEmotions, for detecting facial emotions. I'll hand it off to her. Thanks for coming.
Thanks, George. So this project was part of a professional education program at MIT, and it was the capstone project for a data science and machine learning 4-month, pretty intense program. There were lectures 3 days, 3 mornings each week, and projects and exams each week. And the lectures were done by the actual MIT professors, which made it really fun and interesting. And so this project was judged to be in the top 2 of the people who chose the facial emotion recognition in the class of 126. So I was pretty happy with that. But that kind of relates to my challenges with Google Cloud and their billing approach. But anyway, okay, so the agenda, what I'll go over is the problem that I had to solve, the problem solution, the technical solution, and a little bit on the ROI and what's next.
Yeah, Robert, if you can mute yourself.
So yeah, there's someone. Here we go. So the problem to solve. So in general, happiness is important today more than ever, and entertainment creates that. So if you, let's say George is a movie script writer when he gets on his journalism coat and he sounds like he could be a movie producer, he would want to know what parts of the movie held the highest resonance, what connected the most with the audience. And really, what people do there, he could fill out a survey, he could request a, sentiment analysis, but there's not a good way to gauge to answer exactly that question. So long after I came up with this kind of concept of a problem to solve related to this project, I saw this quote from Ryan Reynolds, and he said this was related to his movie. What was it? Oh, the Deadpool and Wolverine movie that came out this summer of 2024. He said, so he took his 9-year-old and his mom to see it, and he said, I'm not saying other people should do this. Both of them were laughing their guts out. They were feeling the emotion where I desperately hoped people would feel it. And so he was observing them moment by moment and seeing how they were reacting to the script. And this is kind of exactly what my solution would do. So it would map a movie script second by second to a focus group's timeline of feels. And basically that would enable George to easily Hallmark, a Hallmark Channel holiday movie by easily recreating like the pattern of connectedness that happens. And so where I'm at is an emotion detection neural network model that's been trained on 15,000 images. And right now I have an accuracy of 94%. So I came up with this concept kind of as a way to create a business justification around demonstrating a problem. So I kind of back-ended into this concept, but I got the idea when I was thinking about, so I was on a plane from Singapore to San Francisco, and I noticed that there in the plane, in the seat back part of the plane, there was a camera embedded in the seat back. And, I didn't like that. I put a Post-it note over it, but and other people asked me for Post-it notes to do the same. But in this situation where you're watching a movie, let's say your incentive would be if you could get a free movie invite to a premiere, and in exchange for letting the producers figure out where were you bored, where were you sleepy, where were you happy, etc. So the technical solution is something called a convolutional neural network. And by the way, all of this is done, this might sound like a deep learning thing. This is all just some Python libraries. It's so amazing how easy this is to implement via Python. So a convolutional neural network, it's the best network architecture for image recognition. I don't know if any of you have a Tesla or self-driving cars, but if you do, this type of network is what's recognizing objects and images in front of you. So this is the model architecture that that solves the problem. So I had 15,000 images of these teeny tiny squares. I couldn't believe how low resolution they were. So they were just a lot of squares, and I'll show you a bunch of others of facial emotions. It was mostly famous people and public. Well, I don't know where the MIT got the data from, so I shouldn't say that. But I saw there were a lot of famous people in there. But basically, this architecture of convolutional neural network is what solves the problem. And how many of you have ever applied like a filter to your photographs? Like on Instagram? Jacob, do you do that? Do you like post Instagram photos?
I'm familiar with it.
Filters?
Not on Instagram. I actually know how those filters. I actually studied this about 20 something years ago. So
Yeah. So, but convolutional neural networks work very similarly to filter to how applying a filter works, in the sense that you have these little squares that are convolving over the image and creating different layers that are then the convolutional layers are then going into a normal fully connected layer, and it's performing. Then there's a softmax function that does the classification. But it's basically, just think of all these layers as like similar to applying a filter. So I did a lot of experiments to try to improve my model, because it started out at 60-something% accuracy, and I thought, oh my God, I'm going to fail. I really was quite sad when I saw the first accuracy happen. So you'll see the experiments page next, but basically, just to give you an intuition to what's happening, and again, this is for any convolutional neural network that you encounter. And the most typical place where you'll encounter it is, Austin is going to be getting the Waymo taxis, the self-driving taxis. That might be the first place, or in some of your cars. But this is what's happening. This is what's being inferenced live in your cars. So at the beginning, what's happening in these early filters is the large, how to describe it? The large detailed differences are being detected. And then as you progress through the filters, the fine detail differences are being detected. And then these are the emotions that I detected: happy, sad, surprise, or neutral. And so here are some of the experiments I did. So green means it improved accuracy. Yellow means it decreased accuracy. So ReLU is a form of activation, which means it's a type of nonlinearity applied to the neuron values as they're flowing through the neural network. And so if this activation did not exist, then it would just act like a linear regression. Then this neural network would just all be a linear regression. It wouldn't be a neural network, basically. So I experimented with different types of activations, and going from something called leaky ReLU to ReLU, increased accuracy. I did a bunch of experiments that decreased accuracy, and every time I did these, this was, between 45 minutes with each experiment, 45 minutes to 3 hours of time. And this is where I was joking with Jacob and George before we started recording that Google owes me $106.25 because their pricing is so opaque. So I was up against this deadline, and I didn't know that, I thought I was buying like a certain number of minutes and with $100. And actually, when you get into the higher memory models and using GPUs, they accelerate the usage. So let's say I thought I was buying 100 minutes. I actually only had 60 minutes of GPU time to use. And then to make it worse, I couldn't buy more. So anyway, I don't know. Maybe they've improved it, but just beware. So these are some examples of other experiments I performed. Blowing the optimizer learning rate, cutting batch size in half. By batch size, I mean the number of images that are put through at any one time. Increasing validation split, which means the proportion of images put through the train versus test. Adding layers to the neural network improved things a little bit. And I also had the CEO of Kaggle. I happened to go to a conference last year, and I highly recommend this conference, by the way. It's in the Arboretum again. I think it's the first weekend in November. I think it's called the ML Ops World Conference. And the CEO of Kaggle was there, and I showed him this, and I asked him, I asked for advice from him in the audience. If anyone really was an expert at CNNs, what could I do to improve it? And he basically said, 94% is really good. He said, take the win. But I was worried like someone else at the last minute would do better. But it worked out okay. I was pretty happy with top two. But the actual I'll show you. Where do I show you some of the code? This is the actual Python that does the final, after setting up the architecture, which I'll show in the code, the final Python, just these two commands is what does the code to actually spit out the final accuracy on the test data. So one thing that I was really disappointed with when it came to doing this project is I thought that it would be helpful to do transfer learning because, there's been a lot of convolutional neural networks trained in the world up until when I did this project last fall, right? A bazillion, because they're the ones that basically make the money now these days. The generative AI, at least in my company, the generative AI stuff is looked upon as like marketing's toy, not really useful for operational stuff, whereas CNNs actually have proven their value. So I was hoping that a lot of the CNNs that already existed that are downloadable would be good to use, and I could improve my accuracy from using them. But what I found is that at least with facial emotion as the objective function, transfer learning didn't work at all. And so what would be reasons why I couldn't reuse these models, the weights and biases of these models? So one possibility is there was a color mode mismatch in the sense of I was dealing with grayscale images, and a lot of the transfer learning models were trained on RGB. There could have been a domain mismatch problem because I had my problem dealt with facial images, and the world of all these CNNs were objects, and maybe also an image dimension mismatch because a lot of the big models like VGG16 were 224 by 224, and my images were only these little squinty 48 by 48. So that could have caused another problem. Does anyone else have a theory on why transfer learning didn't work? Any thoughts? But I tried it. It was just 73%. So it did, I did get from 60 something to 73%, but you
How
know,
many data records did you have? Did you have over 10,000?
15,000. Yeah.
Okay, that's a good start.
Yeah.
The small resolution is probably your key problem.
Really? This one?
I mean, you need, if you're working against other equivalent low res, then it will work, right? But
Yeah.
if you're working against if you trained on low res and working against high res, then that doesn't match. And
Yeah.
really, to some degree, if you can detect it at low res, then it works. But if it's blurry, again, low res is probably your problem.
Yeah. So here's an example of the data that I had. The other surprise, and this is where I feel kind of silly. The other surprise is just dirty data. I was thinking, since I was dealing with facial emotion data, for some reason, I was thinking it might be cleaner than like numerical data where you might have a lot of dirty data. So if you see this command here, this is, I'm doing a plot.show of neutral images. And, I don't think this guy looks neutral. He's clearly smiling. This little boy here looks sad. Here's Tom Brady. This is supposed to be sad, but he's kind of, to me, though, he's won the Super Bowl. I recognize that photo. Those are happy. These two people down here are neutral. And for whatever reason, the rules of the assignment, I couldn't, for this project, I couldn't edit the data. Like, we weren't allowed to do that. But so I was really annoyed when I saw, like here's another example. This person, this was from the neutral data set. Like, she looks demonic. All these people look surprised. So there was a lot of dirty data. So what I eventually did was I got 3 people on the phone, and we had like a data labeling party to see, how to identify the exact quantity of how many images did we disagree with. And if 2 or more people disagreed, then I labeled it as bad. But anyway, so this is the cliche, but you got to do EDA, exploratory data analysis on your data, and clean it if possible. So let's see what else. So the ROI that caught. Let me see. So this will be a very difficult project, I believe, to actually prove ROI on. There are 8 movie companies that would make enough money to invest. But I still think it'd be kind of cool to, so it'd have to be in Los Angeles in a special screening room. But the cost would be pretty, from a hardware standpoint. They'd have to retrofit the seats, probably $50 cameras in each one would work. And maybe $1,000 a month on inferencing, or probably less now. But the difference, look at this, the difference between using a GPU versus a CPU. When I ran this in using an A100 NVIDIA GPU, 45 minutes, versus the standard Google Cloud CPU, 2 days. So this is also what made me extra annoyed when I ran out of my Google Colab Premium points, and I couldn't buy more. Like, at this, I don't know why, but hopefully they've changed that. So in terms of privacy, with anything like this, privacy would be a huge deal. I would want to have complete, transparent, easy to skim disclosure, and absolutely no personally identifiable information to be added to the image and then deleted after a defined period. So that's basically it for the project. And in terms of the code, so you saw, actually, let me go back to this. Let me go back to the architecture just to show you how easy. So they asked us to not upload the whole code, but I just want to show you. So if you have this image, this photograph, this slide, which you will, I believe, George, if I'll send you this presentation. So you'll have the architecture here. If you have that, and you load TensorFlow into your Google Colab, it is so easy. You just define the blocks according to according to the TensorFlow documentation, add the batch normalization, add the activation, do the max pooling, and just keep doing that for each block. And that's the hardest part, is getting this right, and then experimenting, lots and lots of experimenting. So I had a stand and deliver test we had with the MIT guy that was oh, here we go, that was grading me. And one of the questions he asked, this is a good one, is so what is the purpose of ReLU and how does it work? So my answer was ReLU is rectified, stands for rectified linear unit. It's a form of activation. The activation function adds nonlinearity to any neural network during both forward and backwards propagation. Without activation, a neural network would behave like a linear regression. So this is basically ReLU multiplies the value of the neurons marching through the network with a function that looks like this. So then if the input value is negative, ReLU effectively turns off the neuron. If it's positive, it passes it along as is. So this answer, which I thought was 100% accurate, was assessed as incorrect. And I'm wondering if any of you can spot what is incorrect about it.
Well, I guess you can have negative values, right? Is that it or no?
Say again. I think you're almost correct.
Well, like some weights could be like you could have negative values. So like 0, I guess 0 zeros them out, but it could be like opposite direction. I don't know.
So you are drifting towards being correct. So everything here in this first paragraph is 100% correct. He immediately said you are wrong, and you're confusing ReLU with dropout, because his point was this sentence: if the input value is negative, ReLU effectively turns off the neuron. His point was it doesn't turn off the neuron, it gives it a value of 0.
Right.
And in this sentence is correct. If the input value is positive, this is just has a slope of 1, so it passes it along.
So that's sort of grammar word choice. I mean, we can debate it back and forth. I would say you're correct and he's correct. It turns it off by making it 0.
Well, yeah, his point was, looking back at my experiments, I think I have one related to dropout.
I mean, is there some way to actually turn it off? And then maybe I'm incorrect. If there's some way to turn it off that's different than 0.
Yeah, there is. It's called dropout, and it's basically a way to reduce fitness. I'm sure that
well, then he's got a point.
Yeah,
in databases, right? You got null and 0. Null and 0 are different values, right?
Right. I know. Yeah, he was right that I was wrong. But then the other yeah, it was close. But he was so absolute about it.
Mm-hmm.
But at least he did agree that I had the that my model was in the top 2 of the class. He wouldn't say it was first, but at 94%, but he did say top 2. He doesn't realize that I'm basically in secure need of constant affirmation, and Dad would not be happy with like top 2. But in any event, so the other, so I changed some of his questions into a okay, so here into a a quiz to kick off a paper club call that I go to on Fridays. And so the first question I did was, what is the difference in types of features that are detected in the very first convolutional blocks versus the final? And this is true for any CNN, not just this one. Any guesses? Might have hinted at it.
Wasn't it like bigger features? Like as you get smaller and more detailed, it's just like kind of lines. And then
Yes.
bigger features. Those kind of.
Yes. Completely correct. So the early block detect the big features, and the smile versus the frown, and are the eyes. You could. This is obscured with the sunglasses, but yeah. Oh, here's where I put dropout. So I did change dropout to like 10%. I tried 10% and 20% and 30%, and there's definitely a Goldilocks zone where you're randomly just turning off the neurons versus zeroing them out. You're turning them off. So that's correct. So and then the second one. Okay, so here is where I changed the filter size as well. So the filter size is basically the size of that square that goes all up and down and around each square of the image. And so I tried increasing it from 2x2 to 3x3. And if you remember, I'm already starting with these teeny freaking tiny images. So just 48x48. So if I increased it in all the convolutional blocks, increasing the filter size, it decreased accuracy. But if I increased the filter size in only the early ones, consistent with what, who was the guy that was just talking?
Are you talking about me, Alan Childers?
Yes, consistent with what Alan just said. The early blocks showed the big grabbed or distinguished between the large features of the face. Increasing the filter size there increased the accuracy. But when it was looking for the fine features, I needed to keep it at 2x2.
One of the standard things out of physics that applies in data as well is if, for example, you're going to measure data at every second, then you need to be measuring at every half second. You need to measure at double the resolution of the level you want to actually measure.
Okay.
And, this is somewhat similar.
Yeah. So so give me the relation again there, Alan. So
2 to
when you're,
1.
I understand the help me understand the seconds versus.
If your accuracy needs to be every 10 seconds, then you need to be measuring every 5 seconds.
Gotcha. Okay, cool. Good to know. And then I asked during the paper club call this question, which you pretty much got correct. Then the other concepts. So if you know all these three questions, you know the most important thing about how Teslas work. Seriously. So this is the other fundamental concept, and I got this question from the Austin Deep Learning Meetup, where the guy that works at Adobe, George, what is his name? Sanat, thank you. Where Sanat, he was discussing the two fundamental concepts that make convolutional networks effective and efficient, like the best architecture for processing images. And one is spatial locality. That just means that one pixel close to each other is likely, pixels near each other are likely to be related. I mean, that almost sounds so basic, but it has a fancy name, spatial locality. Then the second fundamental concept is something called translational invariance. Translational invariance means if there's a cup here, or let's say there's a zebra head there, a zebra head is a zebra head whether it's here, 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 or here. It should be interpreted as a zebra head regardless of wherever it is in the image, and CNNs are really good at doing that. Okay, and I showed you the code. And then the second thing I wanted to show, do we have time for one more thing, Jakob?
Yeah.
We do. Okay, so this is my favorite. This is my new obsession. It's a wearable. It's an open source wearable. Like you've heard of all these really expensive wearables that have the terrible reviews. Well, this one is like I don't know, $49. And you wear it around your like a necklace. And I have mine on now. I'm recording. It's going to tell me perhaps that I had too many and et cetera. It's going to critique me. So you turn it on and it automatically transcribes text into your phone. So if I wanted to, I could be seeing the text being transcribed right now live. And my initial interest in this was when I'm helping my relative, my auntie, with her medical care. I want to better understand what the doctor is saying and more easily remember it than scribbling a lot of notes when I'm there with her. And so this has a lot of different plugins that are available for it. And one of them is a medical history summary. And then the other, I think this is the one I'm using, doctor patient notes. And I was going to put, it was kind of personal, so I didn't want to put her medical history. I don't think she would care, but the one I put here to show you a real example of what it looks like. Can you see this? Well,
You're good. It's good enough.
okay. So this, basically this device has saved me $89.26 because I was getting invoiced from a vendor and I was going to pay it, but it didn't sound right to me. And I went back and looked at something, and then I just decided, well, I'll call it and use this as kind of a test to see how well does it do with giving me feedback on how I conducted this phone call. So if you look, so this was a whole a 10-minute phone call, and I asked, what is this invoice? And of course the person said, oh, you're right. Don't pay that. I'm like, well, then why do you keep sending it to me? But anyway, so they said I should disregard the bill. They were going to credit me. And I probably would have paid it had it not been for this device. But anyway.
So
How
it's
did
recording your entire-
how did the device help?
Say again, please.
What did the device do? Like that it saved you? What was going
Well,
on?
I looked back on my earlier, so I guess what I'm showing here is what the device did. And it helped me remember to look for the credit later. I mean, what it did was it motivated me to actually call them and challenge the bill.
But it recorded your day, correct?
Say again?
It recorded your day, and you have a
Yeah.
documentation of your day.
Exactly. But to the point, like it didn't trigger me like this is a wrong invoice because it didn't know the invoice. But you're right. I had it on. I recorded it. Recorded as part of my day, and then I remembered to double check that that I got the credit. Because I saved this as a memory. But
This seems like being very helpful for people with memory issues. What's the name of the product?
it's called an OMI. OMI. It used to be called Friend. And then someone else, I'll put a link to it in the chat because there's this big drama happening now between the originator of the Friend, the original Friend, which is this one, versus someone took like $500,000 and bought friend.com and is trying to make a clone. And he's not shipping any yet. But he's got a lot of investment backing, whereas this Russian guy in San Francisco, Nick Shevchenko, they have this amazing Discord. It's like chaotic. Everyone's running with scissors, but they keep improving it. Like this used to be really buggy at first. And actually, George, when I was going to give this over the summer, I was going to describe this as a great learning tool for Python because I was planning on making these plugins myself. because this is all basically strings, and so you can grab these strings and do whatever you want. You can make your own plugin, train your own plugin, whatever. But before I even had time to like do that, this was already done, and there's a million plugins you can already take advantage of.
Okay, cute. But
Yeah, and so hold on. If you hold on, let me make one point. Let me go back on the screen share. If you get one, this is the original one that I'm wearing here, but this is the brand new one. I literally just got this 2 days ago, and it has like the turn on button for the old one is somewhere on here, and I have to use my fingernail for it, which you guys don't have, but now it's just an easy button press in the middle, very easy off and on, because I don't keep this on for confidential work conversations. But so it's got this easy push button on and off. It's got a microphone at the bottom. I haven't tested that yet. To where if you like lose it, you can have it make a noise. But I really love this thing. It's a total kick.
Oh. Okay, Cameron, we should thank you first of all. So I see people are clapping, but are you open for questions?
Sure.
Okay.
So I have a question. I have a comment question discussion. For the emotion recognition stuff, do you think that they're doing this already at like a mass scale for like focus groups?
No, I
You don't
don't.
think so?
I hope I would have heard about it by now. I think I would have seen something on social media if they were doing it, because someone would have noticed this. I mean, you have to embed.
No, I don't think they're doing it like movie theaters, but like in
Hey, George, I think we had a talk from a company called Zenus. I don't know if you remember them, but they are actually doing this as a business. So it's Zenus, ZENUS.ai. And they actually did, I think the CEO or one of the top guys, they did a talk for us. And what they are doing, they have these cameras in the conference rooms, and then they get the emotion or the reaction of the audience, of course anonymously and all that. Disclosure, I have a few dollars invested in that company as well. So.
Oh, good. Yeah. I'm sure they're doing it in other contexts. I know some retailers tried to do it just to look for interest, and I think they eventually it was too controversial and they stopped.
Yeah, apparently they're doing pretty well. They got some big companies that are doing, as I said, like if you're going to a conference, they don't like anonymize all this data. They don't. I don't think they don't. They're only looking at the emotion of the reaction of the people in the room, but they are not like saying who was there and all that. But yeah, it's a pretty good business. So yeah, I think you wanna go a little further with this idea. We can like monetize in some way.
Does anyone know Ryan Reynolds?
Of course.
I need to connect.
Not personally.
I'm sure many people would like an introduction.
Exactly.
But like, do you think they're doing this at like a much like for focus groups, like before the movie goes into a movie, or before, like for a lot of politicians, they use a lot of focus groups.
Oh, right. Like, that's a good point. Probably.
Or like get a bunch of people, like average Americans, whatever you want to call it, whatever target demographic you're looking for. You get them in a room, and then like without them knowing it, you kind of have these cameras that are like watching their facial expressions, like bet you they're monitoring their pulse and everything, like checking for every message. Like they're just message testing. So much message testing.
God, that's a better, actually, that is a more compelling from a financial standpoint or an investment standpoint. That concept of emotion recognition is more investable than this, I think. I could use this as like well, Jacob would doesn't want me to get controversial, but like a message emotion gauge for different parties to use. Yeah, that'd be cool.
Well, I read a great book called Words That Work by Frank Luntz, who's a little bit of a controversial figure. He's the guy who made the word. He like comes up with the messaging. He used to come up with the messaging for the GOP, and he did like the death tax. And it's like why we call it climate change now and not global warming. It's like because these make us feel different things. It's not about what you say; it's about what you hear. And they were just focus groups, message testing, focus groups, and message testing. And it's like before you had to like wait for you have to wait for them to like react to your sensor or something. But now you can kind of get the unconscious reaction possibly from just like their facial expressions, from like their heartbeat even. I bet they're monitoring their oxygen levels and some crazy stuff. Worth a lot of money to know what words work.
Yeah.
Cameron, there's someone who's Alfredo is writing in the chat. He has two questions. First question is, what library did you use for the CNN training?
I use Google Colab and Google Colab Pro with TensorFlow as the library. Was that TensorFlow and Keras?
Okay, so you actually coded the neural network yourself.
Oh, yeah.
On Keras. Good. This is nice. I love those, by the way. Yeah, this is my personal preference. PyTorch is great as well, but TensorFlow makes things so much easier.
It was great, except for there was all of TensorFlow. Look at this. TensorFlow stopped working one night when they did an upgrade from 2.12 to 2.13, and it was like right before my deadline. So I was really mad at TensorFlow. But you're right.
When did TensorFlow stop working?
I swear to God, Jacob, all TensorFlow for the whole US stopped working at 4 a.m. one night. My night that I needed it.
I think it was something else. Don't blame. TensorFlow is a bunch of code. It won't stop working. But never mind.
It stopped responding.
There are servers and they shut down and they reset servers. It happens in 4 o'clock. It's a very typical
Yeah,
time.
but TensorFlow looks so it has to do with nothing with the TensorFlow. TensorFlow is here. I run TensorFlow on my GPU, so it's like my local machine, so it won't stop working. It's not even connected to the internet.
If she's using TensorFlow on a server, that server could have
Right.
Yeah,
Right.
So it's not TensorFlow.
It's not exactly TensorFlow. It's whatever your server was.
Oh, like Google Colab could be down.
Okay, question 2.
Yes.
Further. Is the training data set of photos available for general public?
Absolutely not. That's what I like. I could be sued for like $20,000 if I make the training data available.
Interesting.
Yeah,
Okay.
they were throughout the entire program. That was the weird thing. Like they do not let their data be released, and they have all these little things embedded everywhere that it's findable if you release the data. But you don't. I think that there are other data sets like that available on Hugging Face. Now the ones I had were 48 by 48. I think on Hugging Face it's slightly higher resolution. So you could still apply this code and this architecture, the same architecture as a starting point. And, don't waste time with transfer learning. This is basically rolling your own.
Yeah, I will just check Kaggle for data sets.
Yes. Hugging Face or Kaggle. They certainly have this data set, but MIT would not let me release this one.
Yeah, they took a while for the labeling. They don't want to, they want to
Yeah,
manufacture effort.
I
suppose.
guess.
They bought it and it's under a certain license. Anyway, question 3. Are you going to publish the GitHub repo for this project?
So they asked us not to. I actually, I have it. Yeah, I have it. I'll post the link. Yes. So they asked us not to publish the entire code. There we go. Oh, is that mine? Yeah, I guess that's mine. I'll check before. They asked me not to publish the entire code so that future students can't just copy it. But I have this in GitHub, and it has the whole architecture. And if any of you are doing a CNN project, I would be happy to collaborate on it with, just give advice. Like there's a paper on something called focused dropout. So we talked about how dropout. Oh, here it is. How dropout, it basically turns off sets of neurons in here as it does the backwards and forwards propagation. It turns off neurons to prevent overfitting. And when you go to 30% dropout, it was too much. It decreased accuracy 10% or 12%, and then 20% was the ideal. But there's a new paper out on something called focused dropout, and I bet that would even help accuracy even more. So I'll put these links. The best way to reach me, I have a little Discord. Do I have it up? Basically, it's a Discord that it's really tiny. It's just for people that are at basically the same stage of learning as I'm at right now, and it's just a repository of tools. And hey, Jacob or George, have we ever done a session on web scrapers?
Actually, you have Robert Zerga. He made one about 9 years ago or 8 years ago. He was one of the first ones that he talked about beautiful soup there. So he's
Beautiful.
He
made beautiful soup?
No, he didn't make. He gave a demo of beautiful soup, and later on there's a guy who was talking about scraping.
Yeah.
I don't remember any meetups about actual
George, you were not even in Austin then. It's 8 years ago.
Okay. Well, I would love if someone here knows someone who's really good at web scraping. I've collected like a list of all the old tools and the new tools with AI. I'd love to see an updated one on web scraping.
That was my first, when I joined my current company, my first team, that was my job. All we did was web scraping.
Really?
That was it. 24/7. It was at scale though, so it was a lot of bot blocking. It was a lot of just faking the whole browser, and you just tried not to get detected as a bot, spoofing everything.
Wow.
Cameron, let's talk to other questions. Anyone has any other questions?
I did have one question.
Go ahead.
I was wondering if you had a model that was trained to take an individual face, and give a score corresponding to the mood, how would that perform on an image with multiple faces in it? Would it still work, or would it just crap the bed?
You'd have to pre-process that to zoom into one face. I think it would probably take down the accuracy if you didn't do that. I'm sure of it. So yeah, you'd have to do one wave of data pre-processing where you zoom down to just one face for sure. In fact, there was was really hoping, another disappointment that I had. Oh, here we go. Data. Can you still see my screen?
Yeah.
So I thought that maybe doing something called data augmentation would help my accuracy, to where like you take an image and rotate it around and resubmit it as new data, or you take it and change the grayscale. And let me go back and look and see. I don't think I was pretty I think it had tragic results on my accuracy. Data, I'm pretty sure. But anyway, that did not, oh, here we go. Yeah, look at that, 19%. I nearly passed out. I was certain this would help. And when I changed like the brightness parameter, changed the range of brightness, that took it down 19%. But don't take what I'm saying as like, if you do your own CNN, it's not, you should still try data augmentation, because there's so many papers talking about how it helps, but for whatever reason on these images, and maybe again it was just because they're so small, it didn't help. Yeah, but and even like the MIT Stand and Deliver interviewer, really, like when he saw this, he zoomed in. When he saw that, like Ian Goodfellow, like one of the godfathers of CNNs, when I applied what he suggested with batch normalization and changing the location, he was very questioning of how this didn't work. But thankfully I could go to like the exact code to show him that it didn't work. But it's really important to have the data.
Okay. Any other questions? Questions going once? Questions going twice?